Welcome back. Today's chemistry lecture is nomenclature, and we're dealing with acids today. In the previous two lectures, we've talked about simple compounds, simple binary compounds, and compounds that contain polyatomics. Today we're going to discuss acids, and there's a few rules with acids, and then frankly some of them you're just better off memorizing. But here we go. So how are acids different? Well, first and foremost, the chemical formula is written different, and that's because it has to do with the behavior of hydrogen. Let's make my ink a little thicker here. Hydrogen. There we go. So the behavior of acids boils down to the behavior of hydrogen. And we're not going to talk a whole lot about why that is. That's for a later lecture, but that's what it boils down to. And all of your acids, because of the behavior of a hydrogen, the hydrogen is written first. So for one of our most common acids, hydrochloric, it's written first. And if you see this hydrogen in front, no matter what the anion is, it could be hydrogen or HS, HBr, H phosphate, they're all acids. If the H is written first, it's probably an acid. Even water can be rewritten because water tends to act like an acid. I mean, HOH is just H2O reorganized. And that's a nice little tip for later. But it boils down to this H. If you see the H in the front, it's an acid, and there's a few different naming rules for acid. First and foremost, it boils down to two things, the rules. The presence of oxygen and the presence of hydrogen. If you see hydrogen written first, then it's an acid. That's your first rule. Find the hydrogen. If it's written first, it's an acid. The second thing you have to do is ask yourself, is oxygen anywhere in the compound? For example, over here you've got oxygen, over here you've got oxygen, but here you do not. Because that's one of our rules. If oxygen is not present, the name of that acid is hydro, then whatever the anion is. So in this case, the first one, we're going to look at this first one right here, HCl, that's hydro, and then the anion is chlorine, so we'll change it to chloric. Where for other compounds you'd add IDE, for acids you add IC. Hydrochloric acid. That's this first one right here. If oxygen is present, you don't actually write the word hydro. That's one reason some of your acids are just sulfuric or chloric or whatever. If there is oxygen present, you don't write hydro. So for this one, we're going to look at the top left here. This is an acid because it's got H, and then it's got a chlorate ion attached to it. So if the polyatomic or whatever is there ends with an ATE, you change it to chloric acid. You just take your polyatomic ion's name, chlorate, and you change it to chloric. And then you add the word acid. You do the same thing for hydrochloric as well. Let me go ahead and fill that in. Okay. Same thing down here. There is an oxygen present right here, but it's not chlorate, it's chlorite. So if it ends in ITE, like in this one right here, it's chlorous acid. OUS tells us that it's less oxygen, kind of like in the old rules for your cations. So I know that can be confusing sometimes, but basically if the oxygen atom is not present in the compound, then it's just hydro whatever your anion is. If oxygen is present, you don't use hydro, and then you add the ic or the us to the end of the polyatomic name. But I'm going to be honest with you. These rules can be confusing, and there's really only a handful of acids you need to know for this level of learning. Keep in mind, I'm teaching to a high school course. And that's these 7, the big 7, the 7 strong acids. Now, that will come into play later in another chapter, but these are the 7 strong acids. And you just need to memorize these. You need to memorize their formulas, and you need to memorize their names. HCl is hydrochloric acid. It's a halide acid. The reason it's one of the big 7 is the H ion completely dissociates, but we'll talk about that later. HI is hydroiodic acid. Iodic. Hydroiodic acid. HBr is hydrobromic acid. Now notice all 3 of these don't have oxygen. That's why it's hydro. Hydrochloric, hydroiodic, and hydrobromic. Over here, you've got your 4 strong acids that are polyatomics. You've got sulfuric acid. You've also got a sulfurous, but it's not a strong acid. You've got nitric acid. You've got chloric acid. And you've got chlorous acid. These are your big 7. You need to memorize these. Plain and simple. It'll save you time, save you effort, and the rules help, but not always. Some other ones you might want to take the time to learn are hydrofluoric, which would be HF, and you also might want to look at phosphoric, which is H3PO4. Those 2 are used pretty commonly, but they're not strong acids. That pretty much completes the lecture on acids, so we'll see you next time when we talk about taking the chemical name and turning it into a formula. See you next time.